The last shape that we're going to talk about that's a quadrilateral is a trapezoid. Okay, so remember at the very top here we have a quadrilateral. One type of quadrilateral is a parallelogram. Now a parallelogram, remember we've talked about opposite sides are both congruent and parallel, opposite angles are congruent, consecutive angles are supplementary, diagonals bisect each other. Then we studied all these types of parallelograms, a rectangle, a rhombus, and if I have the characteristics of both a rectangle and rhombus, I have a square. So then we're going to come over here to the side here, and we're going to talk about a different type of quadrilateral, and that is a trapezoid. Now, a trapezoid more or less looks like this. Now, it can look like what an elephant stands on. That's what we would call an isosceles trapezoid, where both of those sides are congruent. These are considered bases. Or you can have a trapezoid that looks like that, and that wouldn't be an isosceles trapezoid. The thing about a trapezoid, the main characteristic, is that it has exactly one set of parallel lines. Everything over here has two sets of parallel lines. The trapezoid only has one set of parallel lines. That's what makes it a trapezoid and not a parallelogram. There are certain characteristics of a trapezoid. These are about an isosceles trapezoid. So that means that this is congruent to this. Both of the base angles of an isosceles trapezoid are congruent. So this angle is congruent to this angle. This angle is congruent to this angle. Another characteristic is that the diagonals of an isosceles trapezoid are congruent. Now remember, for it to be a trapezoid, it's got one set of parallel lines. Okay, so the diagonals here from that corner to that corner and this corner to this corner are congruent. So that line is congruent to that line. So we'll mark it with 2 since we had marked those. Okay, now remember, these are characteristics of an isosceles trapezoid, not just a trapezoid. Okay. Now, they're going to put this on a coordinate plane. It says ABCD is a quadrilateral with vertices 5, 1. So let's put it on here. 1, 2, 3, 4, 5, 1. There's my A. B is -3, -1. So there's B. C is -2, +3. And then D is 2, 4. And there's your D. So here's my shape. Okay, the first question would be to verify that it's a trapezoid. Now, from looking at this, I can tell you it looks like those two lines are going to be parallel. So I need to find the slope of CD and compare it to the slope of BA. Okay, let's verify that those two are parallel. So use your slope formula on your calculator. And when I do CB, I do -2, 3, and 2, 4. And I get a +1/4 right here. And then when I do BA, I get -3, -1, and 5, 1, which is going to give me a +1/4. So I know for sure that that is parallel to this. Now, to verify it, I need to show that those two sides are not parallel. So they should not have the same slope. So CB, I need a slope of, and DA, I need a slope of. So, continuing on, I have negative 2, 3, and I have negative 3, negative 1. And the slope here is 4. And as long as that's not the same slope, I don't need it to be a 4. If it's a 4, then I have a parallelogram. But you can tell by looking at it that that is not going to be the case. That's going to be negative 1. So I verify that this is a trapezoid because it has exactly one set of parallel lines. This is parallel to this. Then it says determine whether it's an isosceles trapezoid. For it to be an isosceles trapezoid, the measurement from CB would have to equal the measurement from DA. So let's see what the measurement, I'll have to use the distance formula here. So from C to B, I have negative 2, 3, and I have negative 3, negative 1. It has a distance of 4.12. Now let me do DA. So I have 2, 4, and I have 5, 1. And it has a distance of 4.24. Now you can see that those are not the same. So therefore, this is not an isosceles triangle. Or not triangle, trapezoid. So be careful on your looks because it sure looks like it would be, but when you put those measurements in there, you discover that it's not. Okay? Let me verify again. I know this one's right. Let me verify that the other one's right just before we go on. So negative 2, 3, and negative 3, negative 1. Yeah. Okay, so that is correct. So it is a trapezoid, but it's not an isosceles trapezoid. Okay, here's another theorem. It has to do with a trapezoid. The median of a trapezoid is parallel to the bases and is half the sum of the bases. Now, for this to be a median, that would have to be congruent to that. So that would have to be the midpoint. And this would have to be congruent to this. So F would have to be the midpoint of those. This would also have to be parallel to this and parallel to this. That being the case, the measurement of EF, which is the median, is 1/2 of the sum of the two bases. So 1/2 the measurement from A to B plus the measurement D to C. Okay, so the median is 1/2 of the measure of the two bases. So for instance, okay, if I say that EF is 20 and MN is 30, I want to find out what this bottom measurement is. Understand, here's my median, it's 30. It's equal to 1/2 of 20 plus, and we'll call it X, that's our unknown. I'm going to multiply both sides by 2 to get rid of this 1/2. So I have 60 is equal to 20 plus X, or X is equal to 40. So I find out that DG would have to be 40, which makes sense because 20 plus 40 is 60, and 30 is half of that. All right, now this has to do with the angles. I need to find angle 1, 2, 3, and 4. And I know that angle 1 is 3x plus 5. And I know angle 3 is 6x minus 5. I can do these a couple different ways. I know that those angles, they would have to actually be supplementary, and the reason being that right there is parallel to this, which means this is a transversal, which means these are consecutive interior angles. And if you remember, go back to a lot of chapters ago, consecutive interior angles are supplementary, which means they're going to add up to 180. So I'm going to go 3x plus 5 plus 6x minus 5 is equal to 180. So I have 9x equals 180, x equals 20. Now I've got to go through and figure out these angles. So I'm going to plug 20 back in. So I have 3 times 20, which is 60, plus 5. That makes this angle 65 degrees, which also makes this angle 65 degrees. Okay? This is a trapezoid, and this is an isosceles trapezoid, so those two are the same. Then if I plug it in up here, I get 120 minus 5, so this is 115, which makes this over here 115. So angle 1 is 65, angle 2 is 65, angle 3 is 115, and angle 4 is 115. All right, your homework on this is page 442 through 443, 10 through 18 even, and 22 through 28 all.